This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
So, welcome to our show about Reactive Spring. This is Eberhard Wolff, and I'm sitting here with Jürgen Höller. He is from Austria and the lead engineer of the Spring framework, pretty much from the very beginning. And I'm happy to meet him here at GoToCon Amsterdam. What we are going to talk about is how reactive programming will be integrated into the Spring framework. And Jürgen, well, welcome to the show, first of all.
Thanks. Happy to have the opportunity.
And one of the things that I understand is that all the code that goes into the framework has to be Jürgenized. So I was wondering what that actually means.
Well, I have a certain tendency to go, source code and just polish it. So my own term for it is actually polishing. It's just my process of revisiting certain parts of the code base, contributions to the core framework code base, and to fine-tune them, both in terms of source code style and in terms of the actual implementation. So I pay a lot of attention not only to the style, although I do remove spaces and I do align Javadoc, I do all those things, but I in particular pay attention to the efficiency of the implementation, reuse of state, for example, optimize concurrent access to shared state. That sort of attention to the detail is what others have coined the term for, and they call it Jürgenized because I really tend to do it to pretty much all the code in the code base, whether it's originated with myself or whether it was an external contribution from within the team or outside the team. I do it basically to everybody's code. I guess that's part of the meaning as well.
Can you say a few words about Spring and what Spring's goals are? I guess quite a few listeners are familiar with it, but still maybe someone didn't really use it so far.
I suppose so. But in all brevity, Spring as an application framework has the ambition of providing a comprehensive programming model for the challenges in Java application development today. Of course, today is actually an ongoing kind of today. We pay a lot of attention to evolve the framework towards where the challenges are and the challenges will be in Java programming. So we are usually very forward-looking. The application framework itself has quite some history in the meantime, dates back to 2002, 2003 in its origins. But at the same time, it is a very up-to-date, very 2016 era framework. And it's in particular this evolution and adaptability of the framework towards modern day challenges that we are most proud of.
Spring is a whole ecosystem, so there are quite a few other frameworks and tools too. One of the more recent tools is Spring Boot, and it seems to be one of the tools that is most popular right now. So can you say a few words about that and what it actually is?
Indeed, the ecosystem is actually quite extensive in the meantime, and Spring Boot is just a great entry point into the ecosystem. So Spring Boot is actually quite a few things. It is a kind of entry point in terms of dependency management as well. You start with a particular Spring Boot version. You get pre-chosen versions of the core framework, of Spring Data, of several other Spring projects and external third-party projects selected for you, and Spring Boot just brings them in a pre-tested, pre-integrated form. So that's one of its merits, but at the heart of the Boot effort is an auto-configuration framework. So Boot basically is an auto-config story where with very minimal configuration, even zero configuration, you just get started with Spring Web applications in particular, but also other kinds of Spring apps in a very minimal form. A third angle is the notion of embedded bootstrapping and kind of special deployment arrangements like fat jar deployment, where Spring Boot just has a sweet spot in how it allows you to deploy and start your Spring application in rather non-traditional ways. And this is where it connects really nicely with the microservices idea, the microservices architecture. Spring Boot at the heart of what it does is not really a microservices framework in any kind of particularly narrow sense, but it turns out to be a very fine match with what microservices architectures demand, both in terms of the deployments of smaller units and in terms of the auto-configuration effort, where if you have several deployments in mind, each of them might have its particular external services to integrate with, and Spring Boot's management of the particular dependencies of each of those deployment units is also a sweet spot. So Spring Boot is many things to many people, but it turns out to be a very, very popular part of the modern day Spring ecosystem.
The other part about ours is reactive programming, of course. We already did a show about reactive programming with Vernon. It's episode 249. But to get us started here, can you say a few words about what reactive is in your opinion?
From my perspective, reactive is a very overloaded term. Depending on who you ask, you can actually get quite different impressions. But from my own perspective and from our kind of Spring-oriented perspective, reactive is an infrastructural challenge. Our modern-day infrastructure is actually very capable of the efficient use of resources at runtime. However, we need to allow it to actually operate efficiently. Our programming models tend to just make assumptions about the use of resources that prevent the runtime infrastructure from managing them efficiently. It starts with threads, where our programming models tend to just basically occupy a thread, do its work as long as it takes, even with external calls to external systems, data stores and other collaborating systems, and at some point release the thread when you're done processing your current request. This is actually a very resource-intensive arrangement. You have to have a thread pool actually allowing for such long-running request processing on any given thread. Reactive basically turns the idea around and suggests programming models where your processing algorithm is being specified in the form of callbacks, allowing the runtime to call you back when the resources actually allow for processing, when the streams actually allow for reading, when your output arrangement actually allows for streaming output data back. So you're not making assumptions about always being able to talk to your resources. You react to the availability of your resources, both on the incoming end and on the outgoing end. So it's from my perspective, it is primarily driven from this infrastructural need, and some of the technologies out there, like the low-level technologies, are very, very capable of allowing us to do this. The shortcomings are rather at the programming model levels. So this is not a transparent upgrade underneath the covers and everything just magically happens. It really requires us as application developers to rethink the way that we are going about some of our processing arrangements. We need to reconsider, in particular, web endpoint arrangements, HTTP request processing arrangements, to some degree, data store access in general, the use of transactions. There are many implications that follow from this.
At the core, what you're saying is that if an HTTP request comes in, the old model would just take a thread and block it forever, while with the reactive model, an HTTP request or even multiple HTTP requests would be handled by one thread. If they enter the system, or if new data from a data store comes in, then the system would react and that single thread would handle all of those requests. So how do you develop reactive applications in Java? We are all pretty familiar with the servlet model, I guess, and all the other models where you would just get a request that comes in and do your stuff in a linear fashion. If you look at what you just said, then we would need to have something to react to data coming in from the database, an HTTP request that comes in, and so on. So what's the impact on the programming model?
I guess the easiest way to illustrate this is actually the common examples out there in, for example, RxJava, where the idea is to have certain common operators, like say map, flat map, operations that allow you to express processing arrangements for pieces of incoming data as they come in. There's a very close relationship, of course, to the ability to nicely craft callbacks. So Java 8 lambdas, of course, are a really nice fit. The entire programming model suggested by RxJava and co. Really works much better on Java 8 than it ever did before. It does not change the fundamental arrangement, though. You are being called back by a thread chosen by the runtime for processing a particular piece of data that just came in or that is about to be written. So you cannot make any assumption assumptions about the state of the thread. You can't just set up thread locals or have ongoing transactions carried over, as you maybe thought you could do based on the heritage of the serverless programming model. This is a situation where there are benefits to each of the models, though. So it's not just a step forward in every possible sense. The transactional model that we're used to work with does make a lot of sense for certain kinds of applications, whereas reactive programming basically requires you to drop the entire notion of longer running transactions. You interact with resources in very short, small steps, and you're going to be eventually consistent at some point, but you can't just have transactions of several seconds providing those consistency guarantees to you anymore. The reactive programming model landscape in Java is very diverse. So there's a lot of things, not just RxJava, out there. There are very distinct approaches, like the actor model in Akka. There's Vertex. There are plenty of framework architectures that are really suggesting a reactive model all the way through. Whereas our perspective is a little bit more balanced, we actually look at the space from a more pragmatic angle. And the experience level of a Java or Spring development team is a very important factor in its own right. Reactive programming can be uncomfortable. It can even be sort of messy, to summarize at least. So it is a different way to tackle a particular problem space with implications that are not necessarily of everybody's taste.
You said that there are some issues around transactions and reactive. Can you elaborate on that? I mean, when I get in an HTTP request and I do some work on the database, and then again I do some work on the database, this seems to be something that I should really encapsulate in one transaction if I have several different parts of stuff that is done on the database, at least for relational databases. So would you say that this is not the case anymore for reactive applications, or what's your point there?
I would argue it is not a fit for the fundamental idea of using resources just within a short callback. Programming reactively at the entry point level and then going down to the data store, asking the data store to have a connection reserved for you, kind of goes against the grain. It doesn't really work aligned with the thread pool management. So from my perspective, it needs to be efficient all the way through. You need to have efficient use of your thread pool. You need to have equally efficient use of your resource pool, your connection pool underneath. So you might be forced, because of some external constraints of the external data store not allowing you to interact any other way. You might be forced to do it. In some cases, in some corners of your system, in a reactive world, you're typically passing such longer running interaction work off to worker threads, not constraining the availability of your system overall. This is one of the greatest shortcomings of the servlet world, kind of one pool for all HTTP servlet requests. If some of them block against data stores, they are not available to incoming requests anymore, even if those incoming requests could be perfectly handled in a very efficient way with cached responses returned. So you basically sacrifice the availability and responsiveness of your system if your target data stores block in some form. So it is, unfortunately, from my perspective, a consequence of a truly reactive architecture that the interaction with your data stores needs to be rethought as well. You cannot just talk to your relational database as you used to. And transactions, the notion of a kind of longer running interaction with a data store can be translated to some degree, but consistency guarantees, where you're asking your data store to basically create locks on tables and rows for you, is exactly what we're trying to avoid here, because the next thread is just going to come along and have to wait for that lock to be released, which isn't any better than waiting for a thread pool to release a thread to you. My own perspective on it is that it's, if you really want to do reactive, do it all the way through, down to the data store level.
Listening to what you said, it seems that the most important reason for doing reactive programming is, well, efficiency and performance and these kinds of things. So would you agree, or is there any other reason why you would do it?
It is the primary reason. I mean, with the consequences of improving the availability and responsiveness of your system, because the runtime arrangement can always provide, always has threading resources available for incoming requests in some form, allowing the architecture to differentiate between requests that are very easy to satisfy and others that are more demanding. If you're waiting for a data store, well, basically, you're waiting, your thread is being released back to the pool in order to serve somebody else's incoming request, which might be much more efficient to create a response for. So given that both in the JVM world and in kind of operating systems in general, we have limitations on the resources available. You can't just have an arbitrary number of threads. You have to live with some limit being imposed on you in terms of the number of threads. So in particular for applications with highly concurrent loads, there is no other way to scale them without sacrificing availability and responsiveness other than going reactive at some point. Right? Not every application falls into that category, obviously, but quite a few applications or certain parts of common applications out there, the public-facing ones, openly accessible without any login or authentication, where anybody can send any number of requests at any time to those facades. Those are basically the parts of a system that would benefit most. Informational systems, user-facing systems, and of course, systems with just a very high number of users in general.
Okay, I see. Obviously, you're working on Reactive Spring, so why did you start that project?
Our reactive efforts have actually started quite a while back. There were several factors involved. There was an interest, of course, in the team in general. We were very aware of what was going on already in RxJava land, and kind of admirers of some other efforts in the JVM space in the reactive angle. In terms of our own efforts, we have been asked. We reach out to people, and it turned out in conversations that people are facing the constraints, resource constraints in some parts of the systems. So some of those conversations turned pretty concrete. People were already doing RxJava in Spring, so there are already Spring apps out there as we speak here, doing reactive in Spring, right, in a Spring context, in a Spring application environment, using RxJava, some of them even using our own Reactor effort, but basically in a handcrafted style, without any first-class support from the framework itself. Some of those discussions led to very concrete suggestions that there could be first-class reactive support in quite a few parts of the Spring ecosystem, starting from the core framework, where some of the core abstractions that we have kind of at the moment make assumptions about how they are being used, the use of blocking input and output streams, and the use of thread locals. The reactive spin leads to variants of some of those abstractions that are more openly designed towards a callback style, towards back pressure, towards the non-use of thread locals. And so this turned out from a couple of those corners into an effort where we thought like, all right, let's do some R&D here. Let's see what a Spring Web Endpoint model, basically Spring MVC-like model, could look like with a reactive engine underneath, using some of those newly created abstractions underneath, using the Reactive Streams APIs as kind of a foundation for the interaction model, and just seeing what it feels like. Kind of Spring MVC on reactive.
So you mentioned RxJava quite a few times. Can you say a few words about what that is and how it relates to Spring?
RxJava is probably the best known library for reactive programming in Java. Well, it was largely developed at Netflix, actually originated as part of a larger effort with several language bindings. But RxJava has an established role as a common library. It is already a little bit dated in the meantime, since it actually predates Reactive Streams. So the Reactive Streams effort, which is a collaboration between several industry stakeholders, created a very minimal set of interfaces that we call the Reactive Streams API. And RxJava, to this day, is not based on Reactive Streams. It just has Reactive Streams adapters. So it is a kind of early generation programming library, but it is the common reference out there. And in our Reactive Spring effort, in our initial goals, and actually to this day, we aim to support RxJava as a programming model for the user-declared application endpoints. The RxJava observable type, the RxJava single type can be used in the endpoint signatures. But as we move forward with this, there are more modern-minded alternatives to the RxJava types, coming, for example, from our own Reactor project.
What are the features of RxJava? You mentioned observables, so obviously it has to have some callback mechanism.
It's most importantly, it is a composition library. It has a ton of composition operators on observable where you can combine the outcome of one of your callback operations with other operations. You can create whole sequences of processing steps that consume each other's output, whole chains of processing that are fed to an underlying runtime, and where just a whole sequence of callbacks produces the outcome in the end. Observable is actually a huge piece of API due to composition methods, to all those operators. Reactor is kind of coming from a similar angle. The Reactor Flux type and Mono type are sort of similar to observable and Mono, so they are kind of RxJava rethought from a reactive streams based perspective and a little bit more focused set of operators that are sufficient for the 80-90% use case. But in the end, RxJava is an admirable effort in when it started and what it did since. We just believe that for a forward-looking perspective, RxJava 2 is really highly anticipated. They have a plan for RxJava 2. It is intended to be based on reactive streams as well. Just didn't really make any concrete progress yet, or much concrete progress yet. So our Reactor project to this day is the most advanced reactive streams-based composition library out there.
So Reactor is actually a project that is run by Pivotal, just like Spring.
Indeed, it is an independently minded effort on projectreactor.org, but very aligned with what Spring is doing. It is used by quite a few projects within the Spring ecosystem and within the wider Pivotal portfolio as well. And it is our focus, our kind of preferred composition library for the purposes in the Reactive Spring programming model. We expect a Reactor 3.0 release to go with Spring Framework 5 next year. So it is very aligned in that perspective.
So you mentioned reactive streams. So can you say something about that? How does it relate to Reactor and RxJava? What is it? What features does it provide?
Reactive streams is more of an integrational effort than, it's not really user-facing. A very minimal set of interfaces with a publisher, a subscriber, a subscription type, allowing to interact a publisher and a subscriber with some basic means of back pressure, where a subscriber actually requests further pieces of data from a publisher, and the publisher only really starts generating them on demand as a subscriber is able to handle them, to actually digest them. So it focuses on a particularly important part of reactive interaction. The idea being that those pieces come from different angles, different vendors, that application level pieces, data store drivers, web framework endpoints interact through those common abstractions provided by reactive streams. So it is an effort much larger than Reactive Spring. We are working with quite a few of the stakeholders in the reactive stream space, both other framework vendors, but in particular web server implementers and data store companies. So if, for example, Couchbase, there's even a Postgres effort in that direction. There's quite a bit going on where the vendors themselves would provide reactive streams-enabled data store drivers, just naturally allowing for being composed into processing chains that are based on the Reactive Streams API. And the overall promise of our Reactive Spring efforts actually rely on this happening. We cannot just solve the reactive streams, the reactive programming challenges on our own. We can only really solve them in collaboration with the teams behind, say, Tomcat, Jetty, Undertow, Netty in particular, but also the data store drivers over there, for example, Couchbase and others.
So will Reactive Spring be based on RxJava and Reactor and Reactive Streams? Is that what you're aiming for?
let me fine-tune the wording. It goes in that direction, of course, but it is based on reactive streams, very fundamentally. The org.reactive streams APIs are literally at the heart of our abstractions. So they are the foundation that we build on. Our user programming model, the Spring MVC-like reactive web endpoint model, supports RxJava in the user level signatures. So we don't internally use RxJava there. We understand user signatures, basically the application programmer using RxJava in the callback signatures, and naturally bind to it. So we see, an RxJava observable. Underneath the covers, we are reactive streams based, using Reactor as our internal composition library. So we understand, there's an observable, and we can adapt to it. We can interact with RxJava composition APIs as the user chooses to use them. So we are not RxJava based. The idea is, and the prototype has first-class support for RxJava as a user-level choice of APIs in the callback signatures.
And Reactor would just be internal, or is it also something that I could use or should use on the user level?
Initially, Reactor was primarily used for our own purposes internally. We need to have some composition library to implement the reactive web stack on our own end. However, in the meantime, with the effort that is currently Reactor 2.5 and moving towards a Reactor 3.0, Reactor has Flux and Monotypes that are those two primary pieces of API that are very, very suitable for user-level use. They are basically direct equivalents of the common RxJava observable and single types. And we are still in late R&D, early productization stages here. But my current prediction is that the primary user-level choice for newly started code will actually be the Reactor types in the end. We will also support RxJava as it happens, RxJava 2 as it happens. But I see RxJava 1 as more of a transitionary phase. For newly started code in 2017 and onwards, it's probably going to be Reactor or possibly RxJava 2 as it matures.
There are other programming models for reactive applications. So, for example, there are actors. How does what you want to do in Reactive Spring, how does that relate to actors?
Actors are fundamentally a different architectural approach towards the same problem space. From my perspective, I have quite a long history, looking at Akka and also spending a bit of time with the people behind Akka. Akka is a fine piece of engineering. The actor model is a fundamental choice that they made at some point initially, and it seems to be attractive to a certain architectural mindset for sure. From our own perspective, this is basically a fine choice if it fits your purposes. But from our own perspective, we focus on a more traditional style, more Spring-oriented style in the end, where your reactive web endpoint would be a Spring controller class, a Spring controller type, with at-request mapping callback methods. The difference is almost only noticeable when you look closer. The signatures of those handler methods don't expect a pre-bound object, a pre-converted payload as an incoming argument, and they don't return a fully computed response output at the end. They rather have an incoming RxJava observable, for example, or a Reactor Flux, and they happen to return an observable or Flux. They basically are designed to interact with a hot stream. An incoming stream that has not been fully processed yet, and an outgoing stream that is being processed with callbacks coming in as we are able to write further data to the servlet output or to the HTTP container output. Adaptability of that model is one of the sweet spots because we can adapt it to a servlet 3.1 ASIC stream world. It just isn't as efficient as it could be. The same model, exactly the same programming model, can also be run on a, say, netty runtime underneath with the full level, the full exploit of the efficiency that you can possibly get from the model. So we are designing a programming model in a way where it can be run on several engines with a certain focus on netty. Admittedly, it's just a common choice out there for highly efficient network stacks, but also with the ability to run on a servlet, in a servlet container world, even on standard servlet 3.1 containers. But we have an effort going on where we spend time with the Tomcat guys and the Jetty guys, creating more efficient ways of interacting with a servlet-based container. There's a Reactive Streams Commons effort, towards a servlet bridge, where we can obtain efficient handles from a given servlet request, allowing us to interact with it through the Reactive Streams APIs. So there's quite a bit of interesting collaboration going on here, industry collaboration going on here, trying to avoid artificial barriers for efficient processing, allowing us and others to provide common programming model elements, a common programming model style, without making assumptions about a particular runtime in the sense of, I'm bound to Netty or I'm bound to Jetty or Tomcat's binding here. A common, reactively oriented programming model for web endpoints that can be adapted to those several engines underneath the covers. So we're basically back to a very Spring-oriented perspective. There is a little bit of deployment abstraction going on here, of designing your application components once and being able to reuse them in different kinds of deployment arrangements. So we're basically back to a very original Spring promise for the purposes of reactive programming here.
How would that be different if you would be using actors?
React is architecturally just a very unique style. It's basically a message passing model with actors being able to hold state for you. You can kind of have an actor-like arrangement with Spring as well. I'm sure actually some people do this in some form, but the way that we are looking at it is we don't see actors as a kind of as an option that's particularly attractive to the mainstream. We are very mainstream focused in, I hope, a positive sense. We intend to, whatever we do basically, we aim to do it in a way that at least can be attractive to a wide range of developers, in particular enterprise developers out there. My own experiences and also the experiences from others I've been talking to is that the actor model is kind of it is attractive to a particular corner of the space, to particular architectures, to particular processing architectures where message passing is just a natural way of interacting between the components of your system to begin with, where it fits basically your architectural understanding of your own system. But it is not necessarily an ideal match for where most people come from. In terms of the Spring audience or the wider Java Enterprise audience, many of them do REST interaction with JSON payloads or custom payloads. Some of them do messaging on WebSockets, for example. So particular messaging styles, but not really actor message passing, but more like message protocol payloads on the WebSocket channel, bound to WebSocket resources. So we know where people come from. And in terms of our own reactive efforts, we want to take them where they are. So basically keep being focused on REST endpoint architectures, REST payload processing, just in a reactive style. We are not trying to kind of turn them into a completely different architectural model. We allow them to rethink the architecture, obviously, but the idea is that you actually preserve a lot of the architectural investment that you already have, or the architectural understanding of your own system that you already have, and you start using reactive programming model measures, reactive programming model elements in your architecture to solve particular hotspot problems that you may already have or that you expect to be having as a kind of defensive measure. Particularly nice fit with a microservices architecture where some of the microservices would particularly benefit from a reactive approach, whereas others may be just happy the way they are and keep being happy for years to come, the way in a more traditionally architected way. There's nothing wrong with that from our perspective.
We've been talking already about what it means for developers. So you were talking about how there is a different model for Spring MVC for the traditional web framework. Is Reactive Spring only for web applications?
It is, as our initial goal that we're working towards, it is very focused on web endpoint processing. However, it is by no means exclusively designed for it. We spend a lot of time actually rethinking our lower level abstractions, so resource interaction, stream abstractions, that are perfectly applicable to non-web scenarios. As kind of a second step, we have our own messaging abstractions already. We have quite an audience out there doing message-oriented architectures with Spring, and reactive programming model elements coming in there, maybe just as highly demanded as for the web. But our initial stakeholders, so the people that we've been talking to, early adopters, people expressing an interest in early adoption here, they are primarily interested in efficient HTTP endpoint processing. So it's a very pragmatic choice for us to initially focus on it. The wider effort in the longer Spring 5.x evolution will just have other first-class scenarios in mind that we're applying the same principles to. Very much again in a Spring mindset where we reuse stylistic elements across different endpoint models. We're just going to do the same here as people would expect us to.
So you already said that the model will be very much like the old model where you have at request mapping to annotate methods to certain HTTP requests and you would just have a different signature. Is that it? Is that how the model is different, or are there any more details that are different?
Let's just clarify to avoid a misunderstanding that we're reusing stylistic elements from our programming model. So this is not running on the same engine as Spring MVC, and it does not have the full set of identical capabilities. It reuses a lot of the common elements. It's controller classes with instance state, request mapping for the bindings to methods. There are quite a few common things you can express in your request mapping signatures that you can also use in traditional Spring Servlet MVC. But there are also limitations to what you can do. Say JSP rendering, right? Just does not make any sense in a reactive web endpoint model. So you know that you're working with reactive web endpoints. You're not working with an abstract model. You're working with a reactive web endpoint model that is kind of makes a common stylistic impression because it reuses stylistic elements that you know from traditional Spring MVC and other Spring endpoint models. But you know that you're working with a reactive engine with certain constraints in mind, certain things you can do here that you couldn't do in Spring MVC and the other way around. It's also technically two different stacks. So even in Spring 5, there's going to be a traditional Spring Servlet MVC stack, which is pretty much, it is an evolution of what we have now, but it is its own little thing. We're not going away from the power of the servlet model and the power of the existing servlet-based libraries out there. You can't keep doing what you're doing on Spring Servlet MVC without any compromises. In parallel to that, there's a reactive web stack that's kind of independent, both code base-wise and in terms of its runtime characteristics. They really come together at the top end, at the programming model level. That's where the commonalities appear again. So we're doing this with a particular vision that we have in mind here. And we're going to have quite a few tutorials, nicely arranged documentation pieces that are just illustrating both the common parts between those worlds and the strong differences, in particular in terms of runtime assumptions that you can make.
I think I will also add the guides, the Spring guides, to the links for the show because they're really nice to get some hands-on experience with Spring technologies. So why can't you do JSP rendering in reactive application?
Well, for a start, there's not necessarily a servlet container underneath. In contrast to Spring Servlet MVC, the Servlet API does not leak. I mentioned before that we can adapt the Spring Reactive Web Endpoint model onto Servlet 3.1 containers, but the servlet model does never shine through. We are not making any assumptions about servlet characteristics. JSP is strongly tied to servlets, so there's no way to go without. You will be able to render templates, so like trigger a free marker or a time leaf render step. At the moment, that's a blocking operation because the template engines don't really allow us to direct with them in a back pressure driven way. But there's still some way to go. And as we evolve with this, I'm sure there will be, like from ThymeLeaf, or even FreeMarker, there will be ways of talking to them in a more reactively minded style, in a non-blocking style, callback-driven style. So we see those pieces coming together. But even initially, if your template rendering step is very efficient, you're only blocking for a very short period in the end. If the payload's not too large, there might not be that much negative effect to begin with. This is really part of where a reactive web application will differ from a traditionally minded one. You're going to be very focused on also the size of your payloads and whether they're even worth decomposing. Whereas traditional, JSP or template-based apps, they often just render enormously long responses out without even worrying. And so we are aiming for a balance here where people have to be very aware of what they're doing in the reactive world to actually get the benefits. It is way too easy to code sort of reactively and not actually get too much benefit out of it. And that's a bad compromise to have because you are actually spending a lot of energy rethinking your architecture, adapting to the reactive mindset, coding in a different way. You're giving up on quite a few things, starting from long or running transaction boundaries and that sort of thing. You want to get some benefits out of it. So the worst possible scenario is doing it in a kind of half-baked fashion. So we're really trying to do it in a way where Spring MVC, traditional servlet MVC, remains attractive to an audience wanting those benefits, that compromise, that style. My own perspective is that in years to come, a lot of new code will be written with the traditional Spring MVC model, traditionally Spring servlet-based MVC model. There's nothing wrong with that. As mentioned, in the microservices world, you may choose to use the reactive endpoint style in some of your microservices, but not in others. Maybe 80% are traditionally coded and 20% are reactively architected.
Would it make sense to port over a servlet-based Spring MVC application to the new model?
With that perspective in mind that we've just been talking about, I would argue towards no. I would not just port it. If you want to re-architect a particular web endpoint arrangement, a particular microservice that you have, if you want to re-architect it towards a reactive arrangement, that's not really a port. It's a kind of re-architecting of the entire service. As part of that, you may also recode your web layer towards the reactive Spring web style. That's perfectly fine. Porting suggests that you basically take the code and with very little measures, you've got something that delivers benefits in the other world, and it's not quite like that. You could try to do it for very REST-oriented architectures. You could try to do it, but if everything else remains the same, in particular your data store interaction remains the same, you might not get as much benefit out of it as you would think. So in that sense, you might be better off keeping it the traditional way until you actually have a problem, actual demand that suggests that a reactive rethinking of the entire service will deliver significant benefits. And that's when you should touch your web endpoints.
You said that one of the reasons why you would use the new model is basically performance and scalability and so on. When would you rather use the old Spring MVC model even in new applications in the future?
Well, in services, in certain parts of an application where your web interaction is not the bottleneck, you won't get much benefit out of a reactive web interaction model since it's simply not the bottleneck, right? If your web requests just go to a JPA layer underneath and spend a lot of time talking to your database and a lot of CPU cycles on translating the results of that database back to objects, if that's where your bottleneck is, I'd rather spend the time re-architecting that part of the system, the data store part of the system. Whereas if you know that your hotspots are actually at the web layer, you may of course touch it selectively even there. But say a lot of enterprise applications are more traditionally structured, traditionally architected CRUD applications with object relational mapping underneath. For those kinds of services, you're probably better off just keeping them on the Spring Servlet MVC model, or even if new services are being created, architecting them on that model, as long as the rest of the architecture further down the call stack is equally traditional. There's nothing wrong with that at all. It is a very consistent arrangement, very consistent mindset then in terms of transaction scopes and everything else. So it actually is a better fit overall. I'm very much a believer that a particular service or a particular part of an application needs to make architectural sense wholesale from top to bottom.
So we already spoke about how some databases are supporting reactive streams. However, if I look at JDBC, that's obviously a blocking model. So what about non-blocking JDBC? Is that something that we can be looking forward?
It is something that we can hope for being invested in by most stakeholders. The one effort that I'm somewhat familiar with, is in Postgres land, where it's not really JDBC based, so it's kind of an alternative Java database driver, reactively minded. We are going to see more of those efforts for sure. For databases where the backend, the DBMS itself and the network protocol actually allow for reactive implementation style. So it's very dependent on whether the backend of the database can actually efficiently satisfy reactive demands and the back pressure oriented interaction. But we're going to see some of this. Unfortunately, from my own perspective, it's not just the driver style. In a relational, traditionally minded relational database world, you also have strong transaction assumptions in there. You expect rows to be locked for you with certain isolation levels. There are quite a lot of elements in the relational database world that are not an ideal fit for a reactive data store indirection model.
There is a demo somewhere, and I think the databases that you're supporting there are CouchDB, Postgres, and that's it? Or is there anything else?
There are quite a few ongoing efforts. This is also actually a particular thread of our thinking here, is we want to do things at the right time. We don't want to be too early where nobody else basically has reactive streams efforts ready. We hope that by next year, which is our Spring Framework 5 kind of GA target, 2017, first half of 2017, by that time, I hope that more of those efforts actually reach GA status, or at least very close to it, where it just becomes a more attractive model overall.
What about other technologies? I mean, for example, there's JPA, the object relational mapper in the Java space, and that is, as far as I know, based on JDBC. So you can't do JPA in a reactive application.
JPA is based on JDBC for a start, but it's also even stronger in terms of its transactional assumptions. And if you want to make any modifications to your model being written back to the data store, you have to do them within a transaction scope. You have to load the objects within the same scope that you're modifying them in, or you have to merge them back in. So it's almost by design not meant to be used for like very short, efficient interactions with your target data store. It's more meant for a servlet-oriented model where you basically take a request, you know the entire amount of changes that you want to do, you start a JPA transaction, you load all the objects that need to be modified. It's only really efficient if you do all your operations within combined transactions. A little bit longer lived for that reason. So in a transitionary phase in particular, or in architectures where only some of the requests actually go down to the data store level to begin with, it may be perfectly all right if some of those requests then just do JPA as blocking operations and return. In a very CRUD-oriented system where almost all the requests go down to the JPA level, I would argue it's not a great fit. If you want to do a reactively oriented web architecture on top of it, you're not going to be happy with the outcome.
What about HTTP 2? What's the impact of HTTP 2 on Spring MVC, and the whole framework?
I tend to actually refer to HTTP 2 quite often, in particular as a theme for Spring 5 in its own right. Well, I admit it's actually more of an ongoing theme already. We strongly believe, and I personally strongly believe, that we need to embrace HTTP 2. There's no way we can just keep doing things the traditional way in Java land without at least going HTTP 2 for a start. So all the servlet containers, all our servlet-based architectures at least need to make the move towards HTTP 2 for a start, in particular in order to allow the container to do the best possible job given the servlet model, because it works quite nicely. The impact on developers, on application developers, is actually not too strong. HTTP 2 support in the servlet world is largely transparent to the application. It is a change in terms of the server's own architecture. It is a change in terms of the configuration style for the server to some degree. But the application components themselves, they can keep receiving servlet-oriented requests as they are used to. So it is a very straightforward step to take. Upgrade to Jetty 9.3 or Tomcat 8.5 or Undertow 1.3 or higher. Configure them to use HTTP 2 underneath the covers, which is not entirely trivial, but it's basically an effort you should be willing to go through. And then just deploy your existing applications on top of it. If the rest of your IT infrastructure, like your proxies and so forth, are also HTTP 2 capable, you might actually benefit from HTTP 2 very quickly without having to touch your application code much. So it's almost the inverse situation from the reactive programming benefits, where with reactive programming, you have to re-architect your code in order to get the benefits. With HTTP 2, you can leave your code as it is, and through configuration and infrastructure updates, get almost all of the benefits. So in that sense, it's a no-brainer. And this is really a call out to everybody with existing Spring web applications out there. Please consider the HTTP 2 enabled options, Tomcat 8.5, Jetty 9.3 in particular.
So Reactive Spring is probably one of the major new features in Spring 5. What else is planned for Spring 5?
One of our original themes for Spring 5 was JDK 9. It still is, but it's certainly been a little de-emphasized compared to the reactive theme. So in terms of the programming model impact, our reactive programming model efforts and the underlying abstractions, the reactive streams alignment, the preparations for Spring Data, reactive stream support in the Spring Data repository model, all of those things factor back into the core framework. The core framework needs to enable all of this. So this is our widest, broadest, and deepest theme. But just next up is JDK9 now. It's basically in number 2 now in the theme list, not number 1 anymore, is JDK9. There are quite a few nice things we can do with JDK9 internally. Like JDK9 actually is the first JDK to ship an HTTP2 enabled web stack out of the box, support for the ALPM protocol, an HTTP2 enabled alternative to the good old URL connection client. So we're going to embrace all of this for Spring applications running on JDK9. More importantly, we see ourselves recommending the use of Spring 5 and JDK9 quite a bit for the JVM level benefits. Compact strings, the revisions to the G1 garbage collector. There are a lot of really nice improvements to the runtime in JDK9 that Spring applications, in particular microservices-oriented applications, are going to benefit from very immediately. So even without using any of the programming level features in JDK9, there are going to be a lot of benefits to deploying a Spring 5 application on JDK9. So it is an important theme. We are still tracking our efforts towards Jigsaw, the module system, but at the moment Jigsaw is not an ideal fit for our vision of what a configuration story needs to look like. So we're not actually focusing on Jigsaw at the moment. Well, timeline-wise, at this point, it looks like Spring Framework 5 will actually become generally available before JDK9. But we have had that situation before with Spring 4 and JDK 8. We're going to ship best effort early support for JDK9. We will basically go GA first and just declare the JDK9 support not production quality yet, but we are likely to build on JDK9 already, and you will be able to use Spring 5 on JDK9 release candidate builds at that point. So there's nothing wrong with the timelines not matching from my perspective. It is still an important theme. Well, HTTP2 we already discussed is kind of an ongoing theme that has a connection to Servlet 4.0. Servlet 4.0 unfortunately doesn't really make as much progress as we would like it to, but if it starts moving forward again towards a Tomcat 9 being based on it and so forth, we will also embrace Servlet 4.0 to the best possible degree. A couple of other ideas towards alternative configuration styles in Spring. So there's quite a lot of thinking of what we consider doing. But since we're not even in the milestone phase yet, there haven't been any hard decisions outside of the key themes. So there will be the reactive story, there will be early JDK9 support, there will be a strong HTTP2 focus. As we're going through the milestone phase, we're going to see what else makes it in.
Okay, thanks a lot. Thanks a lot for the interview. It was very interesting.
Thanks for having the opportunity. And let's see what everything turns out to in the course of this year. I'm looking forward to it myself.
Yeah, thank you.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio Group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.